Do I have the video feed? Capture, chat, screen share, cameraman. Where the fuck is video feed? Maybe cameraman? Okay, so I can minimize this, I'm pretty sure. All right, everyone, what is going on? Welcome to my channel. My name is Caleb. And tonight, as you can see from the live feed, we have Codecademy Python, a bunch of Mountain Dew, and nothing but time to kill. So if you're just joining, or if you're new to this channel, my name is Caleb, and pretty much I make videos on Codecademy, or really, I make videos for Codecademy and I post them on YouTube. So far, we started the HTML and CSS, did a little JavaScript. So tonight, I just kind of got bored, and we're gonna do the Python. Anyways, okay, so I'm trying to do this live. All right, let's do this then. Cool. So Python, learn the program in Python, a powerful language used by sites like YouTube and Dropbox. So let's go ahead and click continue. But first, we should pull up SoundCloud and get some shit jamming. Let's see. Let's go to explore. See here, Tuesday. I don't fuck with you. This is my shit right here. I don't mind. But anyways, here we go. Cool. All right, so let's go to the welcome. We can hide this for all I care. And reset the code. All right. Or can I turn this down over here? Let's see. Oh yeah. Okay, here we go. 2, 3. Been with me. All right. Okay. All right, welcome. Python is an easy-to-learn programming language. You can use it to create web apps, games, even search engine. Ready to learn Python? Click Save and Submit to continue. So, okay, cool. Welcome to Python? None. All right. Variables. Creating web apps, games, and search engines all involve storing and working with different types of data. They do so using variables. A variable stores a piece of data and gives it a specific name. For example, spam equals 5. The variable spam now stores the number 5. Set the variable myVariable equal to the value 10. Click the Save and Submit. Okay. Seems pretty self-explanatory. And equal to 10. Like that. Sweet, way to go. Booleans, great. You just stored a number in a variable. Numbers are one data type we use in programming. A second data type is called a Boolean. A Boolean is like a light switch. It can only have 2 values. Just like a light switch can only be on or off, a Boolean can only be true or false. You can use variables to store Booleans like this. A equals true, B equals false. Set the following variables to the corresponding values. Okay, cool. So let's go ahead and type in my int, and then so that equals 7, or not plus, but equals 7. There we go. My float equals 1.23, and then my bool equals true. Okay, everything looks good. Let's try and save and submit. So did you not define a variable called my bool? My bool. I did. My int, my float. What did I do wrong? Oh, capitalize true. There we go. So I guess Python is pretty savvy when it comes to fucking capitalizing shit. And coming from like JavaScript and jQuery and these other places, they don't really care for capitalization so much. So you've been reassigned. Now you know how to use variables to store values. Say my_int equals 7. You can change the value of the variable by reassigning it like this. My int equals 3. Try it and see. Change the value of my int from 7 to 3 in the editor. Okay, so right now we have my int equals 7, and then what we're going to do is I'm just going to go ahead and print my int so we get it on the screen. I might just throw it up there for us. And then my int equals 3. Oh, and it's printing my n at the bottom. So we should see 7, then 3. So that just showed us how we can change the variable from 7 to 3. Cool, congratulations, we finished the first section. Excuse me. Whitespace. In Python, whitespace is used to structure code. Whitespace is important, so you have to be careful with how you use it. The code on the right is badly formatted. Hit save and submit code to see what happens. You should see an error message. We'll fix it in the next exercise. So def spam, that probably looks like a function. It probably is a function. Eggs equals 12, return eggs. Okay, print spam, which is probably just going to return eggs, which would be 12. But it probably needs 2 spaces in between here, but let's see what happens. So file Python line 2, eggs equals 12. So and expected us to be indented. So we do that 2 space indent. Let's see what we get. Oh, no, fuck it. Whatever, way to go. We're going to the next one anyways. So white space means right space. Now let's examine the error from the last lesson. So excuse me. Indentation error. Expected an indented block. Yeah, I can't talk. You'll get this error whenever your white space is off. Properly indented the code with the 4 spaces before eggs on line 2 and another 4 before return on line 3. So line 2, there should be 1, 2, 3, 4. And then another line, 1, 2, 3, 4. Okay, so now we should print. Okay, cool. So I guess it's 4 spaces instead of 2. All right, cool. A matter of interpretation. The window in the top right corner of the page is called the interpreter. The interpreter runs your code line by line and checks for any errors. Cats equals 3. In the above example, we create a variable cats and assign it the value of 3. Create a variable called spam and assign it the value of true. So let's just say spam equals true. If we can do our equal sign. And then create a variable called eggs and assign it the value of false. Eggs equals false. And remember, guys, you got to keep these capitalized. Let's just go ahead and try to run this. So we finished that one. So now single line comments. You probably saw us use the hashtag or the pound symbol sign a few times in the earlier exercise. The pound sign is for comments. A comment is a line of text that Python won't try to run as a code. It's just for humans to read. Comments make your program easier to understand. When you look back at your code or others want to collaborate with you, they can read your comments and easily figure out what your code does. Write a comment on line 1. Make sure it starts with a hashtag. It can say anything you like. Okay, so we just say my comment. Cool. Hit. Sweet. So let's run that. So multi-line comments. The hashtag sign will only comment out a single line. Well, you could write a multi-line comment starting each line with a hashtag. That can be a pain. Instead, for multi-line comments, you can include a whole block in a set of triple quotation marks. So triple quotation marks, okay? Oh, cool. All right. That's new. So write a multi-line. So 1, 2, let's get our interpreter. 1, 2, 3. 1, 2, 3. And then we can just say blah, 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 blah. So there's like 9 lines, and it's all commented out. Awesome. Now we're getting the math. Great. Now let's do some math. You can add, subtract, multiply, divide numbers like this. Addition equals 72 plus 23. Subtraction equals 108 minus 204. Multiplication equals 108 times 0.05 or 0.5. Divisions 108 divided by 9. So it's pretty much all the same. All the same operators that you would use in any other language, pretty much. So set the variable count underscore 2 equal to the sum of 2 big numbers. So I guess we just say count underscore 2 equals 1, whatever that is, plus whatever that is. See if that works. Cool. So we get 3,579. So that's how you do math. Exponentation. All the math can be done on a calculator, so why use Python? Because you can combine math with other data types, example Booleans, and commands to create useful programs. Calculators just stick to numbers. Now let's work with exponents. So we have 8 equals 2 times 3. I guess that's an exponent. In the above example, we create a new variable called 8, and then set it to 8. Or the result of 2 to the power to 3. Okay, notice that we use 2 multiplications instead of one asterisk or the multiplication operator. So if you're going to do the power of something, you use two asterisks instead of just one. Cool. Okay. Create a new variable called eggs and use exponents to set eggs equal to 100. So eggs and use exponents. So we just do 10 to the 10, I believe. Try raising 10 to, 10 to the 2. I'm an idiot. So there we go. 10 to the 10 would have been like a million. Ooh, cool. So they got modulos in here too. Our final operator is modulo. Modulo returns the remainder from a division. So if you type 3 mod 2, it will return 1 because 2 goes into 3 evenly once when 1 left over. Use the modulo to set span equal to 1. You can use any two numbers that will leave a remainder of 1 to do this. Well, we just saw 3 mod 2 equals 1, so we'll just use that one again. But we can use anything we want because as long as this number right here goes into this number, it doesn't matter how many times this number goes in, it just has to have a remainder. So really this could be like 6, but if you do 6 mod 2, there's no remainder because 2 goes into 6 3 times, so it'd be 3.0. But if we were to do 6 mod 4, we get 6 minus 4 is 2, so we would get mod 2. We need to do mod 5 because it can go in there once and then we'll have 1 remainder over. So let's try that, see if that makes sense. So we still got 1 again up here in the editor. So that's great. So congratulations, you finished the section. Awesome. So bring it all together. Nice work. So far you've learned about variables, data types, whitespace, comments, and arithmetic operations. Let's put our knowledge to work. Write a single line comment on line 1. It can be anything. Make sure it starts with a hashtag. So we can just say my comment on line 1. Set the variable Monty equal to true. So we're making a Boolean there. Set another variable Python equal to 1.234. So that's going to be a float because we have a decimal in it. And then set a third variable, Monty underscore Python equal to Python squared. So pretty much we're just going to say Monty underscore Python, and then what we're going to do is going to say equals Python, and then what we'll do is just go boom boom with the 2 asterisks and then square that. So that looks good. Hopefully we'll get the green light. Congratulations, we did, and we just earned another badge. We earned the Python syntax badge. Awesome, awesome achievement. So I'm going to go ahead and close this, and next we're going to go do our calculator. So that sounds like interesting shit. And it's right now be a really good time to take a Mountain Dew break. So I'm gonna take a sip of Mountain Dew. That is good shit. There's probably no one in here. Nope, there isn't, but I really don't care. I'm just doing this for the hell of it. I wonder how long of a course this is. Let's go back to Codecademy. I think the Python course is, so it says 13 hours. Let's get this shit done by like 10 o'clock. So the meal. Now let's apply the concepts from the previous section to a real-world example. You finish eating at a restaurant and receive this bill. Cost of meal is $44.50. The restaurant's tax is $6.75%. Tip is 15%. Ooh, that was a good one. That was a Mountain Dew burp. Excuse me. So you'll apply the tip to the overall cost in the meal, including the tax. So first, let's declare the variable meal and assign it the value of $44.50. Okay, so we just say meal equals $44.50, and that's going to be a Boolean. So let's go ahead and save that. So now we're going to do the tax. Good. Now let's create a variable for the tax percentage. The tax on your receipt is 6.75%. You'll have to divide 6.75 by 100 in order to get the decimal form of the percentage. See the hint if you would like further explanation. So let's just say tax equals 6.75, and then we'll just divide this by 100. See if that works. Awesome, it worked. So now that's going to give us a decimal form because we divided it by 100, and we had to do 100 because the decimal was like right here. So if we were to divide by just 10, it would only move it over one decimal place, which would be right here. So there would be a decimal here. But since we divided by 100, the decimal is right here, if that made sense. So the tip, nice work, you received good service. So you like to leave a 15% tip on the cost of the meal, including tax. Before we compute the tip for your bill, let's set a variable for the tip. Again, we need to get the decimal form of the tip, so divide 15 by 100. So let's just go ahead and say tip, and let's just say 15 divided by 100, and let's submit that. Oh, got an error. Did you create a variable called tip? Well, we got that bitch says tip. Oh, there's no equal sign. I'm an idiot. There we go. Oops, looks like the tip is set to 0 instead of 0.015. Bam. There we go. Try that. Fuck with it. Okay. Reassign in a line, or in a single line. Okay, we got 3 variables. We need to perform our calculation. And we know some arithmetic operators that can help us out. We saw in lesson 1 that we can reassign variables. For example, we could say spam equals 7, then later change our minds and say spam equals 3. On line 7, reassign meal to the value of itself plus itself times the tax. And yes, you're allowed to reassign a variable in terms of itself. We're only calculating the cost of a meal and tax here. We'll get to the tips soon. Okay, so right now, what we need to do is the value of itself. So we'll just say meal equals meal plus meal times tax. Let's see if that will work. Awesome, way to go. Now that the meal has the cost of the food plus tax, let's introduce on line 8 a new variable total, equal to the new meal plus meal times tip. The code on line 10 formats and prints the console the value of total with exactly 2 numbers after the decimal. We'll learn about the string formatting, the console, and print in Unit 2. Okay, so right now we just got to overlook this, but I can pretty much just see that it's probably just saying this is going to float to 0.2 decimals, so that makes sense. Assign the variable total to the sum of meal plus meal times tip on line 8. Now you have the total cost of your meal, 7, 8. So to the sum of meal. So I think we would just say total equals meal. Oops, it looks like your printed out is 47.50 instead of 54. Double check the instructions. Assign the variable total to the sum of, okay, so I mean, I guess we just say meal, oh, come back, meal plus meal times tax. Will that work? Looks like it printed out as 50.71. Oh, it's tip. Oh, okay, you know what I can do. Total equals meal, and just change this from tax to tip. All right, you know what? Fuck this. Okay, I'm just going to say tax, meal plus meal, times tip. Okay, cool. There we go. Awesome. So I guess that's all you had to do. I don't know why I made that so complex. I guess I just overlooked tax and tip in the beginning. So next score is strings and console output. All right. Another useful data type is a string. A string can contain letters, numbers, and symbols. Name Ryan, age 19, food, cheese. In the above example, we set a variable name and set it to the string value Ryan. We also set age to 19 and food and cheese. Strings need to be within quotes. Create a new variable Brian and assign it the string hello life. So let's go ahead and say Brian equals hello life. There we go. That looks good. Did you create a variable called Brian? B-R-O. Well, if I spelled Brian's name right, I think I would have passed it. So there we go. Practice. Excellent. Let's get a little practice in with those strings. So set Caesar to Graham. So we got CAESAR equals GRAHAM. And then we have PRALINE equals to John. And then we have Viking equals to Teresa, or Teresa, however you want to say her name. Awesome. Escaping characters. There are some characters that cause problems. For example, there's a snake in my boot. This code breaks because Python thinks the apostrophe in theirs ends the string. We can use the backslash to fix the problem like this. Okay? Fix the string in the editor. This isn't flying. This, okay, cool. So you just have to add that, and that'll escape it out. Okay, great work. Each character in the string is assigned a number. This number is called the index. Check out the diagram in the editor. C equals cats 0. N equals Ryan 3. So you got 0, 1, 2, 3. I mean, that makes sense. In the above example, we create a new variable called C and set it to C, the character at index 0 of the string cats. Next, we create a new variable called n and set it to n, the character at the index of the string Ryan. In Python, we start counting the index from 0 instead of 1. On line 13, assign the variable fifth underscore letter equal to the fifth letter of the string Monty. So this is going to equal to, so we just say Monty, and then we do this little bracket, and then we just do 4 because that would give us the fifth. So let's try that. So yep, we got that because this is 0, 1, 2, 3, 4, which would have been y, which really would have been 1, 2, 3, 4, which would have been the fifth. But if we were to put 5 here, this would have ran us over one more because you see right here, we start with 0 like in Python. So instead of this saying Python and this just said monthly, let's try this right here. N T H. Spell that right? M-O-N. Oh, there's no H. Monty. Okay, so pretty much what we just did here is we put 4 because really we want to get the fifth letter. So to us, this is M is letter 1, O is letter 2, N is letter 3, T is letter 4, and Y is letter 5. So once this is get the index of 5, well, to get the fifth index of Monty, that would really be 0, 1, 2, 3, 4. So this would be the fourth. That's why we put 4 here. So because the index starts with 0 instead of 1. But if it were to start with 1, we'd get 5. But if we were to put 5 down here for our index, we obviously would have got an error because there's not another character in Monty. So hopefully that makes sense. If not, oh well. Un momento, we're going to take another drink from this beautiful Call of Duty Advanced Warfare, which is a pretty badass game. And I'm like on my 3rd Mountain Dew, so it's about halfway gone. But I do have more. About a whole 24 pack. I'm about to drink every single one of these bitches. That's good, that's good, that's good. Okay, so now, string methods. Great work. Now that we know how to store strings, let's see how we can change them using string methods. String methods let you perform specific tasks for strings. We'll focus on 4 string methods: len, lower, upper string. So let's start with len, which gets the length, the number of characters of a string. Okay, cool, so length. On line 1, create a variable named parrot and set it to the string Norwegian blue. Or Norwegian blue. On line 2, type len parrot, or really it's going to be length of parrot, which will tell us how many characters are here in this text. After the word print, like so, print len parrot, the output will be the number of letters of Norwegian blue. Okay, cool. So right now we just have to make the parrot. I'm going to say he equals to NORWEGIANBLUE. There we go. And now what we do is we just say print length, and we want to say parrot, and that looks good. Let's try that. Awesome. So now we got 14. So we really come here and count up all these spaces. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. You count the blank space, that's going to be 10, 11, 12, 13, 14. So it just counts every character. So as you saw, we got 14, and there's 14 here, so the computer doesn't lie. Lower. Well done. You can use the lower method to get rid of all the capitalization in your strings. You call lower like so, Ryan.lower, which return Ryan. Cool. Call lower on parrot after print on line 3 in the editor. So pretty much we just say print parrot dot lower. And we should get everything. As you see, the N and the B are now not capitalized. So cool. Upper. I guess this makes everything 100% lowercase. A similar method exists to make the string completely uppercase. Call upper on parrot after print on line 3. So pretty much we say print parrot, and then we just say upper like so, and then the whole sentence should be all uppercase, which it is. So cool. String. So now let's take a look at the string method, which is a little less straightforward. The string method returns a non-strings into strings. For example, string 2 would turn 2, which is a number, into a string that just has the number 2 in it. You tell the difference between these because this one, you see, it doesn't have quotes, as where any string in Python has to have quotation marks around it. So create a variable pi and set it to 3.14 on line 4. So right here we're just going to say pi equals 3.14. Nope, there we go. So now we have to call string pi on line 5 after print. So right now we just say string, and then we're going to say pi because that's the variable we're passing in. Did you create a variable called pi? Oh, I put pi instead of pi. There we go. So we just have 3.14, which is, this is now a string, where it's printing out as a string instead of a number. Dot notation. Let's take a closer look at why you use len.string and string object, but dot notation such as string.uppercase for the rest. Line equals roar, len lion, lion.upper. Methods that use dot notation only work with strings. On the other hand, len, or the length method, and the string method can work on other data types, which that makes sense. So you can only use the dot notation for upper and lower and stuff like that. You can only use those on string data types. But these other methods, like length, you can use that on arrays. You can probably use that on anything you want. Objects, you can just get it whatever the fuck you want. And then the string, well, you can, that obviously that takes anything, whether it's a number, a float, like a Boolean. I mean, it takes that and it turns it into a string. So that's all that does. So that's why those can work on any other data types. So in line 3, call the length function with the argument ministry. So print then the length of, probably have to put this in quotation marks, ministry. And then on line 4, invoke the ministries.upper function. Oh, wait, no. Never mind. I just realized ministry is a variable up top. So now we just say ministry, MIS, what am I missing here? Oh, TRY dot upper, calling that function, see what that does. So we got 27, and then the military of Silly walks. So that's it. So next, let's go to print. Printing strings. The area where we've been writing our code is called the editor. The console, the window in the upper right, is where the results of your code are shown. So obviously this is the editor, and this is the console over here in this little gray box, or black box, whatever. Print simply displays your code in the console. Print Monty Python to the console. So I'm just going to copy this right here, and then we're just going to go right here and paste that in, and make sure that print is lowercase. And there we go. Awesome. Printing variables, great. Now that we've printed strings, let's print variables. Declare a variable called the machine goes. So we're just going to copy this. So I don't feel like typing it. I'm kind of lazy. And then give it the value of ping. So we're going to copy that as well. And we're just going to say equals and paste that in there. So we got ping. And then go ahead and print the machine goes on line 6. So I'm just going to copy this again because it's a shitload to write. And we're just going to say print. Let's go down here on line 6 and say print and then paste that in there. So we got ping, awesome. That's supposed to be on line 5, but I really don't care. And then it gives us an error like I thought it would. So now string concatenation. concatenation, whatever. You know about strings and you know about arithmetic operators. Now let's combine the two. Print life plus of plus Brian. Oh, and that's concatenation or constantation. I'm gonna go with that one. This will print out the phrase life of Brian. The plus operator between the strings will add them together one after another. Notice that there are spaces inside the quotation marks after life and of, and we can make the combined string look like 3 words. Combining strings together is called concatenation. Let's try concatenating a few strings together. So let's give it a try. Print the concentrated strings spam and eggs on line 3, just like the example above. So we're just going to go ahead and say print, and then we'll just say spam plus, spam plus and, which has a space, and there's a space between this, and then we're going to say plus eggs. There we go. Let's try that. It looks like you printed spam and, oh, well, I can't fucking type. I put eggs instead of eggs. There we go. Awesome. Spam and eggs. Sweet. Explicit string conversion. Sometimes you need to combine a string with something that isn't a string. In order to do that, you have to convert the non-string into a string. Print I have, and then right here we're using the string conversion of 2. So we're converting the number 2 into 2, or really into a string, really. And then we're adding coconuts, okay? The string method converts non-strings into strings. In the above example, you convert a number 2 into a string. You convert the number 2 into a string, and then you fuck whatever that word is, and then strings together like in the previous exercise. Now try it yourself. Run the code as is. You get an error. Use the string to turn 3.1 form into a string, and then run the code again. So we get an error. It says string. So it's pretty much saying that cannot concatenate the string and the float object. So pretty much just saying you can't add a float, which is this number right here, because it's a decimal, and you can't add strings together. But if you were to concentrate them with the string method, like so, bam, that now turns the 3.14 into a string. So it's almost kind of like casting in other languages. So string formatting with module part 1. So when you want to print a variable with a string, there is a better method than concatenating strings together, like hello, mod s, mod name. The module operator after the string is used to combine a string with variables. The percent operator will replace a %s in the string with the string variable that comes after it. Okay, cool. Take a look at the code in the editor. What do you think it will do? Save a minute. So if we go ahead and read this. So we see here we have this one, and then we have this one. So it says, it's going to say, because this is string 1, so this is going to go to the first one, because this is, obviously this is the first one in here. So it's going to say, let's not go to Camelot. 'Tis a silly place. And that's what it's going to print out. Let's go to Camelot. 'Tis a silly place, like I thought. Awesome. We were so smart. Formatting with the percent part 2. Remember, we use the percent operator to replace the %s placeholders with the variables in parentheses. Name Mike, print hello, %s, %name. You need the same number of %s terms in a string as the number of variables in the parentheses. So %s, %who, %s, %s, night, say, ni. So that will print out the knights who say ni. Cool. Now it's your turn. We have a bunch of underscores in the code to show you what you need to change. Inside the string, replace the 3 underscores with a %s after the string, but before the 3 variables, replace the final underscore with a %. Hit and save and submit code. The answer to the question in the console will pop up. Type in the answer and hit and enter. Okay, so we have name, raw input. What is your name? Quest, raw input. What is your quest? Okay, so it's going to ask us for raw input. So it's print so what is your name? Right here, we're just going to go ahead and say %s. Your quest is going to go ahead and say %s. And your favorite color is, we're going to go ahead and say %s. And remember, we're going to have to do %s again, like so, or really not %s, but just a %. And then say name, quest, then color. And then what this is going to do is probably going to give us a pop-up box that says, what's your name, what's your quest, and then like, what's your favorite color, and then it's going to be like, bam, right in the editor. Let's try it. Yep, just like I thought. What is your name? I'm going to go ahead and say Caleb. What is your quest? To drink Mountain Dew. And I'm going to go ahead and say blue. So here we go. So your name is Caleb, your quest is to drink Mountain Dew, and your favorite color is blue. Awesome, awesome, awesome. So that's pretty cool. We kind of just made like a little program there and didn't even realize it. I'm out of that Mountain Dew. Need to open up another can. There we go. That is good. Well, we just got an hour left to do. So let's go ahead and get started. And now, for something completely familiar. Great job. You learned a lot in this unit, including 3 ways to create strings. Alpha, Bravo, string 3. Okay, that's cool. String methods. Len, Charlie, delta.upper method, echo.lower. Okay. Printing a string. Print, foxtrot. Advanced printing techniques. G equals golf, H equals hotel, print, %S, %S, %GH, we'll just say golf hotel. So pretty much let's wrap it up. Line 3, create the variable myString. I'm just going to go ahead and copy this, pop over the line 3, bam, and set it to any string that you like. And I'm just going to say Mountain Dew. There we go. Line 4, print the length of my string. So we're just going to say print, then the length. And then we're going to say that's my underscore, then string, like so. Then we are going to say print the uppercase conversion of my string. So once again, we say print my underscore string dot upper method, like so. Let's run that shit. So we got 6 Mountain Dew, then none. So we earned another badge. Awesome, awesome, awesome. Let's go on to date and time. So the date time library. A lot of times you want to keep track of when something happened. We can do in Python using datetime. Here we'll use datetime to print the date time in a nice format. So click statement submit from datetime, import datetime. Okay, cool, none. All right, cool, whatever. Getting the current date and time. We can use a function called datetime.now to retrieve the current date and time. From datetime, import datetime, print datetime.now. The first line imports the datetime library so that we can use it. Okay, so it's pretty much saying from the datetime library, import the datetime library, I guess. Or the datetime class. I'm not really sure what it's importing, but we're just importing the datetime library. So the first imports the datetime library so we can use it. The second one will print out the current date and time. Create a variable called now, then store the result of datetime now in it. Then print the value of now. Okay, cool. So right now we're just going to say now equals datetime dot now, which is a method, and we're just going to say print now. So we got the date and time. Awesome, 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 awesome. Extracting information. Notice the output looks like this: 2013, 11, blah blah blah. What if you don't want the entire date and time? Okay, so now we have now that year. So now we're getting the more methods here. Now that year, now that month, now that day. You already have the first 2 lines. In the third line, we take the year and only the year from the variable now, store it in the current year. In the 4th and 5th lines, we store the month and day from now. Instructions. On a new line, print now.year. Okay, make sure you do it after setting the now variable. And now it's date time. Okay, so we just got to say print now dot year, like so. Well, it does say a new line, so let's just say print now dot year. And print out now dot month, so say print now dot month, and then print now dot day. Let's see if that will work. So we got 2015. Really, then we got the month, and then the day. Which it's not really the second, but I mean, I guess I guess we can go with that. I mean, it's probably the second if you're Eastern time, which is probably what it's doing right here because they were getting 12.3. So, I mean, it's probably thinking that we're Eastern time, which I'm not. We're Mountain time. So, as you can see, it's only 8:58. So, hot date. What if we want to print today's date in the following format: month, day, year? Let's use a string substitution again. Remember that the percent operator will find the percent as placeholders in the string on the left and the strings on the parentheses on the right. In the above example, we print 2014-02-19. If today is February 19, 2014, but you are going to print out 02-1914. Instructions. Print the current date in the format or form of month, day, year. Change the string so that it uses a / character in between the S placeholders instead of a hyphen character. Okay. Rearrange the parameters of the right to the right of the percent operator so that you will now print now that month, then now that day, then now that year. Okay, cool. So pretty much we just got this, and then we just gotta do it like this and like this. 2015 1 2. Cool, we got it. And then we got year, month, day, which really it wants month. Print the current date in the form of month, day, year. So really we need to do month and day, and we'll say year. And we should get 1 2 15. 1 2 15. Okay, cool, awesome, way to go. I don't know why it gave us the green light on the one just then. I mean, we didn't have it in the right form, but it let us pass. But now we corrected it, and now we're still passing because we're cool. Pretty time. Nice work. Let's do the same for the hour, minute, and second. Date time, import, date time, dot now, hours, minute, second. Cool. So we can do the same exact shit as the day. In the above example, we just printed out the current hour, then printed out the minute, then current second. Now we can again use the now dot print to time. Okay, similar to the last exercise, print the current time in the pretty form of hour, minute, and seconds. So we're just gonna say hour, minute. Well, yeah, it was a minute, and then it's gonna say second, and then it wants us to have the characters. Make sure you have it. Okay, so instead of the / just have these little semicolons. Print that shit. 358 4. Cool, awesome. So let's go ahead and go to the next one. Grand finale. We've managed to print the date and time separately in a very pretty fashion. Let's combine the two. Okay, cool. The example above will print out the date. Then on a separate line, it will print the time. Let's print them all on the same line as a single print statement. Print the date and time together in the form of month, day, year. So we just gotta do, let's get in front of this again. Let's do %s / another percent. Oh, that ain't percent. %s / %s again, and then a space. And now we're just gonna say now dot month. Then we're gonna say now dot day. Then we're gonna say now dot year. Make sure you separate each of and every one of them with the parenthesis. That looks good. So traceback file line 4 module name day is not defined. Month, day, year. What did I type wrong? Now dot month. Oh, there we go. So cool. There we go. Awesome. So what I did there, I just had a column instead of a period. That's all. So congratulations, we finished this course. Let's go on to the next one. Control and flow. You know, we were like zooming through this. Still no one's watching, but it's all right. Wow, there's a lot of print shit. So go with the flow. Just like in real life, sometimes we like our code to be able to make decisions. The Python programs we've written so far had one-track minds. They can add 2 numbers or print something, but they don't have the ability to pick one of these outcomes over the other. Control flow gives us the ability to choose among outcomes based on what else is happening in the program. Check out the code in the editor. You'll see the type of program you'll be able to write once you've mastered control flow. Click Save and Submit to see what happens. Okay, so pretty much if I'm just looking at this, def clinic print, so we're seeing that you just enter the clinic. Do you want to go to the door? Then it's giving us a raw answer. So we're gonna have to put in the, we're It's asking us for an answer, so we're putting in the raw input. Type left or right. So type left or right and hit enter. So we just say left. You see down here, it's got a bunch of different else ifs and ors, and then it's going to go ahead and print congratulations. Cool. So we finished that. Compare closely. Let's start with the simplest aspect of control flow, comparators. There are 6 of them. The first one is equal to, which is 2 equal signs. The second one is not equal to, which is an exclamation mark, then an equal sign. Then we got less than. Then we have equal to, which is the less than or equal to, so which is less than the sign, then equal to. Then we have greater than. Then greater than or equal to is the same exact thing with a greater than sign, then equal sign. Comparators check if the value is or is not equal to, greater than, or equal to, or less than, or equal to another value. Note that the equal to compares whether 2 things are equal, and the one equal sign assigns a value to a variable. Keep that in mind. If you use one equal sign, you're assigning something. Okay, you're not checking it. If you're using 2, that's whenever you're saying, hey, does variable A equal variable B? But if you just say variable A equals variable B, it's going to assign whatever variable B is to variable A. Okay, hopefully everyone followed that. If not, I'm sorry. Just take another sip of your Mountain Dew. And before too long, you'll understand. So the instructions are, set each variable true or false depending on what you think might be the results for. Example, 1 is less than 2 would be true because 1 is less than 2. Set the bool 1 equal to the result of 17 less than 324. So bool 1, we did this one for you. Okay, so it's true. Okay, set bool underscore tool equal to the result of 100. So that would be true. It's 2 times 50 is 100. And then that one would be true as well because 19 is equal to 19 or it's less than it. So is it greater than? That one would be false because negative 22 is not greater than 18. And this one says true if 99 not equals 98 plus 1, which is 99. That would be false as well. So cool, we got everything right. Let's go ahead to the next one. So compare a little bit closer. Excellent. Looks like you're comfortable with the basic expressions and comparators. But what about extreme expressions and comparators? Let's run through the comparators again with more complex expressions. For each variable to true or false, depending on what you think the result might be, set bool underscore 1 to the result of 20 minus 10, which is 10, which is greater than 15, which is false. Damn it, they did that one again. Okay. So the next one is going to be 10 plus 17, which is, 10 plus 17 is, 27. I'm an idiot. And obviously 3, like fucking to the power of 16 does not equal 27. Remember that this can be read as to the power of 3, which is about 43 million. So yeah, that's going to be false. And then the next one says 1 to the power of 2 is 2, or really it's just 1 now that I think about it, because yeah, it would just be 1. 1 to the power of 2 is 1. And then less than equal to negative 1, that would be false because 1 is greater than negative 1. 40 times 4 is like 160, which is greater than negative 4, which is true. And then we have this to the power 2, which that would be false because it is equal to 100. So try and submit that. Cool, way to go. We got everything right. How about the tables of turn? Comparison results in either true or false, which are Booleans as we learned before in this exercise. Make me true. Bool underscore 1 equals 3 less than 5. Which that would be true because 3 is less than 5. Let's switch it up. We'll give the Boolean and you'll write the expression just like the example above. So make me true, Boolean 1, 3 is less than 5. We already did this one for you. Okay, cool. Make me false. We'll just say 1 is greater than 2, which obviously that's false. Make me true. We'll just say 10 is less than 20. Make me false. 100 is less than 1. Make me true. 100 is greater than 1. Cool. Awesome. Oh, shit. We need to do something right. Do you remember to use at least 3 different? Oh, fuck. We got to use 3 different ones. Okay. So 10 is, let's say, not equal to. And then we'll say this one equals to. I guess try that. Cool. There we go. We had to use 3 different ones of them, which we did. Congratulations. We finished the section. Let's go on to the next little section here. Zooming by these with just minutes. To be and or not to be. Boolean operators, true or false, something. Boolean operators compare statements that result in the Boolean values. There are 3 Boolean operators, and in which checks if both the statements are true, or which checks if at least one of the statements is true, not, which gives you the opposite of the statement. We'll go through the operators one by one. Okay, let's save and submit. Get the next lesson. And the Boolean operator and returns true when the expression on both sides of and are true. For instance, 1 is less than 2, which is true, and 2 is less than 3, which is true. So that statement would be true. 1 is less than 2, which is true, and 2 is greater than 3, which is false. But since both of these aren't true, we're getting false back. Let's practice with and. Assign each variable to the appropriate Boolean value. Set bool underscore 1 equal to the result of false and false. Okay, so I guess we just say copy and paste. Set Boolean tool equal to the result of whatever the fuck this means. So let's just say that. And set Boolean 3 equal to whatever that is, like so. Let's paste that in there. Set Boolean 4 to whatever the fuck that is. I really don't feel like doing this. Hopefully we're doing this right. If we just copy and paste it, and then we just say true and true again. Let's paste that. Let's submit. It's probably going to be an error. But no, it didn't. Cool. So I guess we did something right. Or, the Boolean operator or returns true. At least one expression on either side of or is true. For example, 1 is less than 2, which is true, or 2 is greater than 3, which is false. But since this one is true, it just happens to be that when you use the or operator, you only have to have one side of it being true. So that's going to be true. But if you have something that says 1 is greater than 2, which is false, and then you have 2 is greater than 3, which is also false, both of them result in false, is also going to be false. So if you ever use the OR operator and one side of the operator is true, it's going to always result in true. But if you have both sides result in false, it's always going to be false. So time to practice with OR. So set Boolean 1. So pretty much I guess we should get to copy all this stuff again, because you and I both don't feel like sitting here and figuring out this shit. So, I mean, we could, but, I mean, it takes time to do that. And, I mean, if you really want to, you can sit there and decipher it yourself, but you don't have to. I mean, as you can see, you just got to copy this and assign it to that, and then save and submit. But if we really wanted to, 2 to the power 3, well, 2 times 2 is 4, and then 4 times 2 is going to be 8. Is 8 equal 108, or 108 module 10, which will just give you a remainder 8, which that is true. And then it's or Cleese equal King Arthur, which is false. So, I mean, that's going to give you back false, but I mean, whatever. So not. The Boolean operator not returns true or false statements and false or true statements. So, for example, not false will evaluate the true, while not 41 is greater than 41 will return the false. Because if we look at this statement, 41, it pretty much just first ask ourselves, let's forget about the not for a second. If we look at the expression of is 41 greater than 40, well, that's true. But since we have the not operator in front of it, whatever the answer is, it's going to pretty much just flip it. So if it's true, it's going to be false. But if it's false, it's going to be true. And since this one was true, and then we say the not in front of it, then we put the not operator, it's going to result in false, which is why we get false. So now I'm pretty much just going to say not true for the first one, and then we'll just say that, and then we'll just say, here's my jam right now. It's like some crazy stuff playing on SoundCloud. Yeah. Right now would be a good time to take another drink of my Mountain Dew. Pretty much just copy and paste the code. You can double not. So if we do not false, which is true, and then not true, which is false, it's still going to result in false. Awesome. Way to go, guys. So this and that, or this, but not that. So pretty much, I guess we can read this. Boolean operators aren't just evaluated from left to right, just like arithmetic operators. There's an order of operations for Boolean operators. Not is evaluated first, and is evaluated next, or is evaluated last. For example, true or not, false and false returns true. If this isn't clear, look at the hint. So pretty much not is going to be the first one. So if we look at anything, so right here, this one's not true. So this is going to result in the true, okay? Then, so pretty much now we have true and false, okay? Which that's going to result out of the true and false is going to result in false. And then if we do true or false, that's going to result in true. That's how we get true in our, I mean, you can look at the hint, but I just explained it. Parentheses ensure your expressions are evaluated in the order you want. Anything in parentheses is evaluated in its own unit. So pretty much, that's pretty self-explanatory. Let's keep scrolling down. And let's see. Oh, scroll down. So assign true or false as the appropriate for bool 1 and through bool 5. So false or true or not true and true. So we're just going to copy this. And once again, we'll just paste that in there. And then we'll just copy this again. I think, honestly, they're supposed to make you figure this. Like, I think like they want you to figure this out on your own. But, I mean, why waste your time when the interpreter will do it for you? I mean, the Python console will figure this out for you and assign the right value. So, I mean, kind of cheating, but I mean, kind of at the same time, you're still not cheating because why work harder when you can work smarter, you know? So now we're on mix and match. Great work. We're almost done with the Boolean operators. Bool 1 equals 2 less than equal to 2, which would be true. And alpha is equal to Bravo. So we got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which should that be true as well. So this time we'll give the expected result, and you'll use the combination of Boolean operators to achieve the result. Remember, Boolean operators are and, or, and not. Use each one at least once. So make me true. So we just say 1 is greater than 2, and 2 is greater than 3. Oh. Wait. Let's say 10, because 1 is not greater than 2. 2 is greater than 1. There we go. Make me false. 1 is greater than 3, which would be false, or 3 is greater than 10, which would also be false, which would result in false. Then make me true. Well, we can just say not not false. There we go. That's pretty simple. And then make me true, and we'll just, oh no, just fuck it, say true. So there we go. Congratulations. So now we have conditional statement syntax. If is a conditional statement that executes some specified code after checking if its expression is true. Here's an example of an if statement in syntax. If 8 is less than 9, which is true, print 8 is less than 9, which is obviously true. In this example, 8 is less than 9. In the check expression, and print 8 is less than 9 is the specific code. If we think the print statement will print to the console, set response equal to yes. Otherwise, set response equal to no. So response, we don't know. Answer, left. If answer equals left, which it does, print, this is the verbal abuse room. You heap of the paragraph. Equal to, response equal to, wait, so if you think the print statement will print to the console, set response equal to y. Okay, yeah, we'll just say y. Oh, looks like you need, looks a bit off. Check the hint. Oh, okay. Set response, we're not on the parenthesis, that's why I just typed in y. There we go. Cool. So yeah. If you're having, let's have some practice with if statements, remembering that the syntax looks like this. If some function, semicolon or colon, block line, block line, block line, blah. Looking at the example above, in the event that some function returns true, then man, hold on, give me a second. Okay, anyways. Looking at the example above, in the event that some function returns true, then the indented block of code after it will be executed. In that event, that it returns false, then the indented block will be skipped. Also, make sure you notice the colons at the end of the if statement. We've added them for you, but they are important, so don't forget them. In the editor, you'll see two functions. Don't worry about anything unfamiliar. We'll explain soon enough. Replace the underline on line 2 with the expression that returns true. So if 1 is less than 3, we just turn. And then it says replace the underline on line 6 with the expression that returns true, line 6. And we'll just say 2 is greater than 1 because that's pretty simple. If you do it successfully, then both successful. Okay, so obviously these are both successful. Going to the next one. Else problems. I feel bad for you, son. The else statement complements the if statement. And if else pair says if the expression is true, run the indented block of code. Otherwise, run this code after the else statement. Unlike if else doesn't, excuse me, depend on an expression. For example, if 8 is the greater than 9, which is false, we'd skip this first code block right here. Then we'd jump down to the else, which is going to be printed out, and it says I get printed. Complete the else statement to the right. Note the indentation for each line. So let's see. We answered this tis but a scratch. Def black, which is the connection. Answer return true. Make sure this returns false. Okay, we'll just say false then. And then return. Make sure this returns false. Is that all you have to do? I think that is. So cool. Let's go to the next one. I got 99 problems, but a switch ain't one. Elif is short for else if. It means exactly what it sounds like. Otherwise, if the following expression is true, do this. So if 8 is greater than 9, print. I don't get printed because obviously 8 is not greater than 9. So we're going down to the next else if. Else if 8 is less than 9, print. I get printed. Since that is true, that pretty much just ends the code block, or pretty much ends the whole if statement. But if that wasn't true, we jump down to the last one, which is else print. I don't also get printed. So last resort, the else would get printed. But since we followed true through this code block, that gets printed. Whew, man, I'm talking so much. In the example above, the else if statement is only checked if the original if statement is false. So on line 2, fill in the if statement to check if answer is greater than 5. If answer is greater than 5, return 1. Then on line 4, fill in the elif so the function output is -1 if the answer is less than 5. So we go ahead and say answer is less than 5. And that is it. So right now, if the answer is greater than 5 on the first one, we're going to print out 1. But okay, so we run this the first time. We're plugging in 4 for the answer. So is 4 greater than 5? No. Else if 4 is less than 5, obviously it is. So we're going to return 1. And then let's see, and then we're going to plug in 5 as no, it's not. So we're going to get -1, 0, and then I guess 1. Let's see if that works. -1, 0, 1. Cool. Yeah, we're right. Awesome. Congratulations. Next exercise. The big if. Really great work. Here's what you've learned in this unit. Comparators, Boolean operators, conditional statements. Let's go to the grand finale. Write an if statement in the flying circus function. It must include if, elif, and else statements. At least one of an or not. A comparator, a comparator equal to, not equal to, less than equal to, greater than, or greater than equal to. Finally, the flying circus must return true when evaluated. Don't forget to include a semicolon after your if statements. So this is making a function if, start coding here. So if okay, so at least one, okay, right, it must include if, so okay, now, okay, let's make sure we have our else, and then we'll just do some like underscores and then the colon again. And then second thing is, so we did number one, at least one of an or not. So if 1 equals 1 and 2 equals 2, which result in true. Don't forget to indent. We already did that. Don't forget to indent the code inside this block. Okay, so and what's this return true? If okay, must return. Okay, so cool. So we must return true. So we'll just say return true. Else if I mean, are we passing in? We're not really passing. Else if we'll just say 1 is greater than 3, which is false. We'll just say return. I mean, you don't really have to make a return statement. And then else, we can just say we a comparator and then use return true. So else, 3 not equal to 3, which that is obviously false, but I mean, who cares? We'll just say return. Well, that'd be false anyways. I think this has to come back just 1. Let's try to run that. An exception was raised while running your code. The console window for the error message. File Python line 12. Boom, 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 boom. Invalid syntax. Okay, well, bitch. How about that? Still nothing. Well, motherfucker, I think you should just do that. Fuck with it. Okay, so I mean, I just deleted that and just put else. Yeah, I don't know why I put the I don't know why I just did that. I mean, whenever you do else, else is like your final option. I don't know why I put an expression there after it. Else is your final there. So that was stupid of me to do that. Anyways, congratulations. We finished that one. Let's go on to Pig Latin. I wonder how many things are in this. Let's see here. Codecademy. Taking in a little drink. Damn, we're only like 19% done. Damn, we've done a lot though. So we've got Pig Latin, doing some functions, doing some lists, student, teacher, loops. Shit, there's a lot of stuff in here. Okay, so maybe this will take a little bit longer than I expected, but I mean, for like 2 hours, 1, 2, 3, 4, 5. We've done a shitload of for like 2 hours. Let's kill this Pig Latin right quick, because it's only like 11 exercises. Okay, cool. So we're making a Pig Latin game. Ahoy, or should I say, oh yeah. Please print the phrase Pig Latin. Okay, copy, print. Oh, come back in here. Here we go. Oh, can I type? Can I type? I can't type. I can't type. Bam, Pig Latin. Cool, next one. Oh, I should probably read this. Input. Next one, you should ask the user for input. Name equals raw input. What's your name? Print name. In the above example, raw input accepts a string, prints it, and then waits for the user to type something and then press enter or return. And the interpreter Python will ask, what's it wouldn't ask that, but it would ask what's your name. Once you type in your name, hit enter, and it will be stored in a name. No way, that's fucking awesome. On line 4, use raw input, enter a word to ask the user to enter a word, then save the results of raw input in a variable called original. So line 4, we're just going to say original, ORIGINAL, and then we're going to say equals raw underscore input, because we're getting the raw input from the console. Enter a word. Well, it would help if we put a, and did that, and did that, and did that. And let's just say pop. Cool. Way to go. Check yourself before you wreck yourself. Next, we need to ensure that the user actually typed in something. So if laying empty string is greater than 0, run this block, maybe print something else. That string must have been empty. Check that the user string actually has characters. Write an if statement that verifies the string has characters. Add an if statement that checks that laying original is greater than 0. Don't forget the... Okay, so pretty much we're just going to copy this right here. And then we're going to say this, and don't forget if, and then bam. And then we're going to say if this actually has some characters that print the user's words, so just say print. And I'm just going to delete that because I don't feel like typing original. So we're going to print the original. And then we're going to come back and say else. And we're just going to be like, well, else. We're just going to say print empty. You fuck with it. Cool, let's try that. Pop. Cool. So if we run it again, just click enter, it's just gonna say empty. Cool, so we made it work. Check yourself some more. Now we know we have a non-empty string. Let's be even more thorough. X equals J, 1, 2, 3. X is alpha, hashtag false. In the first line, we create a string with letters and numbers. The second line runs the function as alpha, which returns false since the string contains non-letter characters. Let's make sure the word the user enters contains only alphabetical characters. You can use is alpha to check. For example, use and a second condition to your if statement in addition to your existing check that your string contains characters. You should also use is alpha to make sure that it only contains letters. Don't forget, keep the semicolon. Okay, so is an original, or I spelled that wrong, original dot is alpha. So this is going to say, well, if we have a length, oh, that should be greater than 0. And original is alpha, print original, else. Okay, that should work. Cool. Awesome. We're like fucking geniuses. Pop quiz. When you finish one part of your program, it's important to test them multiple times. Use a very... Okay, so we just try to run this again. Let's just say something like that. So we're going to say empty. So, cool. Awesome. A, B, C. Now we can get ready to start translating the pig line. Let's review the rules of translation. You move the first letter of the word to the end and then appendix suffix A. Example, Python is ithmpay. Let's create a variable to hold our translation suffix. Create a variable name pyg and set it equal to the suffix A. So we're just say pyg equals A, because we're Canadian, eh? So word up. Let's simplify things by making the letters in our own lowercase. Okay, the .lower function does not modify the string itself. It simply returns lowercase version. In this example above, we store the results back into the same variable. So just say equals string. Okay, cool. We also need to grab the first letter of the word. So we'll just use the index of it, which would be index 0. Remember that we start counting from 0, so not from 1. So we access the first letter by asking for index 0. Okay. So pig A, original, raw input, inner word, if len, original 0, original as alpha. Create a new variable called word that holds the lowercase conversion of original. So, I mean, I guess we'll just do this in line 2. Word equals. Well, we'd have to do this after we get the raw input. So word that holds the lowercase word. Okay, so we just say origin or original. Fuck, I'm an idiot. Word equals original dot lower. There we go. Create a new variable called first that holds the word. Okay. So then we'll just, I guess we can just say first equals, or well, we'd say word, and then we just say the index of that word, which we want the first one. See if that works. Neat. Cool, awesome, it works. Move it back. Now that we've have the first letter stored, we need to add both the letter and the string stored in pyg to the end of the original string. Remember how they concatenate an example strings together. So, greeting, hello, name, dy. Welcome, greeting plus name. Okay, on the first line, after where you created the first variable, create a new variable called new word and set it equal to the concentration of the word first in py. Okay, so, I mean, we got word. Now we're going to say new word, and then we're going to say it equals first. Oh, to the concentration of word first. Oh, fuck, we didn't even make, okay. On a new line after where you've created the first variable, we didn't even make a fucking first variable. Did we? No, we did, okay. Okay, cool. Okay, I'm an idiot. Okay. I lied, we did make the first. Okay, new word equals word plus, after we do the word, we're going to say first, and then we're going to say pyg, because that's going to be the pig Latin shit. Say pop. Well, give us back pop. Pretty sure it's supposed to give us back pape. But what are we printing? Printing original, which is just the word. But I think if we were to print the new underscore word, see what that would give us. I still feel like it's going to give us pape. Yeah, it did. Because we still never split this off. So let's see here. What are we doing wrong? So pyg is a. So that's just the original. So that's giving us the word. So word equals original dot lower. Okay. And the first equals word 0. And then new word equals word. I think we could split this from like one. Let's see. How would you get that? I think you just do it like that. I think that would work. No, it's like fucking stupid. Oh well. Fuck it. Oh well. Because we're still getting pape. Oh, that's weird. Okay, so oh cool, 1,000 exercises. Cool. Alright, got that bitch like 10 times. Ending up, well done. However, now we have the first letter showing up on both the ending. Okay, cool, here we go. So S equals Charlie, print S0, prints. Oh, okay, that's what it was. It was a colon 1 through 4. Okay, first we need to create a variable S and give it the string Charlie. Why the fuck we gotta do that? String Charlie. Next, we access the first set of Charlies in the okay, the index. Remember the positioning. Then okay. So that's all we have to do. We just say new word equals word with the index of 1 to. Oh well, no, we could do. We could say because we're not gonna know what word they're putting in here, so we can just say original dot lang. Damn, we are smart as fuck. Fuck, no, we didn't. See the console error message. File line 5, module line 5. What did I do wrong here? Thought I did that right. Oh, I did that backwards. Okay, so it's ling, then original. Or, okay, I guess we can do new word. Well, no, it wouldn't be. Use one language word to do that. Okay, I mean, we could try that, but I feel like that wouldn't be right. But whatever. Try that shit. Say pop. I guess it did work. Well, yeah, because the new word is equal to the word, which the word word is a bird. Okay, that makes sense. Testing, is this thing on? Yeah, you should now have a fully functional pigmatic translator. Trust your code thoroughly. Be sure everything is working smoothly. You should also take out any print statements you were using to help debug. I mean, we didn't have any print statements, except for that one and that one. You make sure your translator is working. Just say you want to click save and submit the code. Cool. I mean, awesome. So we got the Piglatin badge. That's pretty cool. You know. Now we're getting into functions. I mean, as much as I want to sit here and do functions, there's still no one watching the shit. But I mean, it's pretty cool though. I mean, we could still do it. I mean, we still got like another. Oh, maybe functions will be the last. I mean, should I do functions? I mean, we just did. Well, no, functions is a whole nother thing. So I mean, we just killed a good amount. I mean, we could do functions and lists and dictionaries and other shit and loops and exam statistics, advanced topics in Python. Python gets pretty fucking advanced, especially whenever you start getting. Well, I mean, you get into classes and other stuff in Java. And you get into object-oriented programming. This would be pretty cool, the file input and output. That way you can get in there and see what you're like doing. Yeah, I'm enjoying this. All right, anyways, guys, hopefully you like this. Until next time, stay tuned for another live event. I'm probably take this down, to be honest, but I had fun doing this. All right, guys.